So this is another Comstor Hero session, but also most importantly, it's for every partner out there. This session is about Firejumper, right? So before we get started, though, you guys know where the bathroom is, so take your breaks when you need them to. The session will be recorded, and this is at the end of the session where we can have some interaction in it, so you guys can send in questions through the Q&A panel. I'll be answering them if you guys have any questions at the end of the session. So just recapping Comstor Heroes, that's a program for partners, so a loyalty program for our Comstor partners. It's about learning, experiencing, and selling, and all throughout you get points for the activities that we propose you guys. This is one of these activities, right? Attending these webinars, going through the later on exams for Firejumper is part of Comstor Heroes. Great. Cool. So what are we talking about today here? So today we're talking about Firejumper, Visibility and Segmentation Track, Stage 2. All right, so there's a lot in that sentence right there. And we're focusing on the pre-sales role. So a couple of weeks back, I went through Stage 1 for Firejumper. If you guys have not gone through Stage 1 yet and you need the content, yeah, just engage me, engage someone at Comstor. We'll be able to share that with you guys, so that you go through the online exam, which is free, and you are ready to roll and ready to take on Stage 2. Cool. So what are the session goals? So just get you registered for Firejumper Visibility and Segmentation Stage 2. The link is in the presentation here. We're going to share that with you later on, so you can just click on that link there, but I also have the full link at the end of the presentation. Go through the summary of the content. So a summary of all the content that Firejumper Stage 2 requires. And finally, this will enable you to give a go at the exam. You'll be a lot more ready to take on the exam for Stage 2 for that track. These are the session goals, right? So just a recap on Firejumper tracks and stages. There are 4 stages overall. So a couple weeks back, we went through Stage 1, which was Security Essentials. Just ask us for the content. You'll be able to take on the exam successfully. I'm quite certain of that with the content that we shared. And now what we're doing is Stage 2. So we're going through technical aspects of products so that you guys can take on the exams on Sales Connect. These are free exams once again. And just recapping, what are the 4 tracks and what products are embedded into what tracks. There are 4 tracks in total. Our products are split in these 4 tracks, or security products are split into these 4 tracks. And visibility and segmentation is what we're looking at right now. So today we got a lot to talk about. We got Stealth Watch, Titration, ICE, and Duo. Titration and Duo are highlighted there, are in bold, because they're new additions to this Firejumper course, right? So that's a very fresh for everyone. So if you need to learn about these products, this is a session for you, right? That's all good. Cool. So let's get started then with Stealth Watch. So Stealth Watch, as you may know, it's a family of products, right? It's when you talk about Stealth Watch, you're talking about network visibility, basically. And to that extent, we have 2 products in that family, which is Stealth Watch Enterprise. Stealth Watch Enterprise is meant for enterprise network monitoring. This means that very large customers will be looking into the solution, because it allows them to do full on-premises visibility with all their hosts, all their servers. They can create granular policies in their environment based on Stealth Watch Enterprise, and they can fully customize the policies and the visibility that they want to gather with this product. Stealth Watch Enterprise, however, does not cover public cloud services. So it's great for full on-prem environments, but it does not cover public cloud environments as of now, right? And since it's enterprise grade and enterprise focused, getting started with it, it's quite can be a little expensive for our New Zealand market. For our New Zealand market, I believe that Stealth Watch Cloud, our second product in that family, is ideal. What Stealth Watch Cloud is a SaaS-based product, so it's completely SaaS-based. It's a cloud-based dashboard that you can basically export flows from public clouds. All the major ones are supported, including AWS, Azure, Google Cloud Platform, and others too. So you can send flow data from those public clouds into your StealthWatch cloud management dashboard. And you can also send data from private networks that you have. So branches and your headquarters, just deploy a virtual machine in them, export flow data from those branches over to your StealthWatch cloud management dashboard, and that's it. And you get a full visibility across all your environments from the same dashboard. So StealthWatch Cloud is easier to get into because it's also simpler to deploy. It's got automated tuning, so it basically does its job on its own. It's not as granular as StealthWatch Enterprise, but it is great for customers that are needing visibility and have no knowledge of what's going on their network. So in summary, StealthWatch Cloud would be a SaaS-based offering of the StealthWatch family, and StealthWatch Enterprise would be the full on-premises package that we offer, right? So in the StealthWatch product family, we have SaaS-based offers and we have on-premise offers as well. Today, however, we are focusing only on StealthWatch Cloud because, as I was telling you guys, I believe this is more compelling and more interesting for our New Zealand market. Now, what is StealthWatch Cloud? So StealthWatch Cloud is a solution to provide you visibility on your environment. So knowing everything that's going on your network, knowing every host, seeing every traffic flow between hosts, understanding what is normal, so creating a baseline of traffic, be alerted if anything changes from that baseline, to finally give your agents and your security SEs knowledge and information to actually make changes on what's needed. And all the while, StealthWatch Cloud will allow you to perform forensic analytics on past events as well, right? So it's gathering data for up to 30 days in arrears. It will keep that data for up to 30 days, and you can perform an analysis on past events as well. But also, you will keep data for longer if you need to. It's just a matter of setting it all up completely. So this is effectively what StealthWatch Cloud does, right? And it allows you to perform forensic analysis of past events. What does it deliver in terms of value? Simplicity and efficiency, right? It's easy to deploy and easy to manage. Completely cloud-based dashboard, and it's super easy to set up. That's the main getaway here, and it even can check the amount of encrypted traffic that's coming and going through customers' environment. So if they need to know for compliance reasons how much of their traffic is encrypted, StealthWatch Cloud will allow them to do that. So what does StealthWatch Cloud use to create a baseline and to understand what's going on the network? Well, we use something that is called dynamic entity modeling. This provides complete visibility and precise alerting to security-related events only, right? It collects lots of inputs, right, such as IP, metadata, system logs, security events, passive DNS, so on and so forth. And it gathers that sort of data for up to, well, not up to, but it gathers that data for 36 days to create a complete baseline of the environment. So 36 days is the average baseline period that StealthWatch Cloud needs to have an understanding of what's actually going on the network, right? And during that period, then it's gathering all data from multiple sources and learning from them. Finally, it's applying an algorithm in every single thing that it learns. This algorithm, it's basically called dynamic entity modeling. And dynamic entity modeling is then going to define, according to the traffic we've seen, what is the role of the machine or host that is sending that traffic across. What are the ports and protocols that device continually access? What connections they continually make, and they should be making. What are the rules? So do they need to communicate internally only or externally? And how much data is being sent to and from this device in a given period of time? So this is all visibility information that you absolutely need in case you want to have full control of your environment, right? And having that done automatically and automated by this platform is the real value behind it. So the real kick here behind dynamic entity modeling, it's that StealthWatch Cloud is automatically classifying these network entities into roles and then modeling their behavior. Right? Finally, we are then identifying every entity in the customer's environments automatically, right? So big value there for customers who don't even know what's running on their network, what's connected, plugged into the network. You can just set up a StealthWatch Cloud trial and provide them visibility and some value behind that, right? You're then going to be able to detect, track, and profile what is going on in the network. And of course, this is 100% endpoint agnostic, right? You did not, StealthWatch Cloud would not only be looking for hosts that are Windows hosts or Linux hosts or even just Cisco switches and routers. No, it does that. It profiles everything on the network, no matter what vendor is actually running on the network, and all sort of operating systems as well. So detailed at the end of the day, it will provide you then detailed visibility for every entity as well. So you can see on the left-hand side here a screen grab of the StealthWatch Cloud dashboard. So before you had the graph, and now you're simulating as you scroll down that page, you would then be taken to the summary and the details of everything that went down, everything that happened to that host. So you can see what's the IP address related to that host, when it was connected, how many connections it started in the past day or previous or that given period of time, how many alerts have been opened for that host, and so on and so forth. So every single thing that is happening here is given to you guys as part of the visibility that is acquiring from those devices. So traffic statistics, active traffic profiles, time and day of usage, it can all be seen for all hosts in the network. And at the end of the day, it will create then this traffic profile on every entity. So as part of this dynamic entity modeling process, traffic profile statistics are tracked and modeled. For example, if you're troubleshooting a slow server, for example, or a machine, you can reference the connections that you're seeing on the graphs, that you're seeing on the reports. And then you can look at the attempted or connections made at a given period of time, compare that to other days, and then quickly establish if there was a spike in a given period of time here that shouldn't have happened, for example. And this will just give you insights that you wouldn't have otherwise, right? Finally, it's dynamic entity modeling will also establish then profile behavior, right? So it is profiling every single host and every single endpoint on the network against multiple roles. So those roles are predefined roles. You cannot customize roles. So StealthWatch Cloud will basically be looking at traffic from everything in your network, and it's going to try and put them against the roles that it has available. So it's got over 30 roles available, and well, they're all very relevant to modern networks, I would say. So Kerberos nodes can be seen. Android hosts can be profiled as well. Apple iOS devices, database, DNS servers, domain controllers. That's important. Terminal servers, so on and so forth. So when it sees and it realizes that a host traffic profile matches one of those roles, then it basically assigns that host to that role, and you can with some certainty identify what's going on in your network and what's running on your network. Finally, all the traffic flows that we're gathering, that StealthWatch Cloud is gathering, comes up as observations, right? So traffic flows are also observations. That's what observations are. They are facts about the network, right? What observations tell us is actually everything that's going on in the network, but they did not all, but not always observations relate to alerts, right? So observations is everything that's going on in the network. Some observations will be alerts. Most of them will not be, however, because they're just regular traffic coming and going through the network. And what you can do with Stealthwatch Cloud then is finally look at every single observation for every single host in your network, right? So you can see observations for specific hosts on your network. See observational details as well. So this is on the left-hand side here is a look at what observations you have for a given host. And on the right-hand side here is details about that traffic, right? So what sort of traffic is coming and going from that host on your network, how much of that traffic went through, or even for when it happened, right? So this is observations, and this is the sort of intelligence that you can gather from Stealthwatch Cloud. All the while, dynamic entity modeling is doing this to then establish this baseline, understanding what is the role of that machine, what traffic have we seen in that machine for the past few days. So we're actually gathering data in the blue phase here, just identifying, classifying the roles. Then the data starts staying in the environment. The 36 days go by. This is the full baseline period that I mentioned earlier. Finally, however, on this full baseline period here, if anything that is obviously malicious identified, we are going to alert that. We don't need a baseline for something that is obviously malicious, like, for example, a port scanner or a DNS abuse. So these activities are not common in enterprises. So if any of these activities happen, no matter when, they're going to be alerted, right? So you don't need to wait 36 days for these alerts to be flagged on your environment. However, for anything that is common to enterprises, but it's not part of that host environment, you need to wait at least 36 days to understand if that's part of that host flow. Finally, it reaches a point here where we have a baseline for that host, and after that period, then we start looking for changes, right? So at one point here, dynamic entity modeling or algorithm we established a baseline, and at one point here, we identified that there's a new external connection observation happening at that host, right? So it could be as simple as just one packet to an external packet. That will be enough to flag that as a change in our environment. So that new external connection then has increased in activity, and a new high throughput, for example, connection started and was created in the environment. Finally, what that will do, it will create an alert. An alert will be triggered to Stealthwatch Cloud, and that will be put in your customer's dashboard so that they can take action upon that. And how do observations, they work together? Well, observations are, alerts. Alerts are about giving you, empowering your team to actually perform their security operations center activities and troubleshooting activities more efficiently. So we don't want to alert every single thing that is happening on the network. What Stealthwatch Cloud is doing is optimizing the alerts as well, right? So the alerts that they create are oftentimes regarded as very helpful by customers. So you can see that over 90% of Stealthwatch Cloud alerts are rated as helpful by current customers, and that is important, right? And what are some of the most common alerts, for example, that Stealthwatch sees? Excessive failed access attempts, for example. So knowing when someone is trying to brute force a system, for example. The DOS and application attacks, yes. Also, potential data exfiltration, or knowing when an internal connection blacklist is happening. Geographically unusual remote access, or a persistent remote control connection. So these things are very well, they're red flags in our environment, and these are very common to happen on customer environments. And these are, suspected botnet interaction with inbound port scanner. That's not supposed to be happening on a network, right? So these are some of the common alerts that you would be seeing on Stealthwatch Cloud, for example, among many others. There are over 80 types of alerts that Stealthwatch Cloud has inbuilt. These are um, preset alerts that cannot be customized, but Cisco is always creating new alerts based on what's commonly being used by attackers out there. So with Stealthwatch Cloud, what are the deployment options and what's the licensing like? So as I've been telling you guys, Stealthwatch Cloud is about multi-cloud environments and on-premises as well. Great. When it comes to public cloud environments, though, we need to understand what is a shared responsibility model, which must be something that everyone is across nowadays. But just to recap on that, the shared responsibility model for public cloud environments states that a cloud provider is responsible for the security of the cloud, right? Of their own cloud. So they're securing their own data center, their own information, of course. However, it is the customer's responsibility to secure everything that they put in that cloud provider's environment. So everything that is in the cloud is the customer's responsibility. So therefore, it's important to keep this in mind. So things that customer needs to be worried about is customer of data of their own customer, applications that they put in public cloud environments, operating system that they're maintaining. So if they stand up a new Linux host or a new Windows host on public cloud environments, you need to take care of that, right? It's not the cloud provider's problem, it's yours. Being able then to understand what's going on in your environment is your responsibility. This is why Stealthwatch Cloud is so important in our environment, especially nowadays and here in New Zealand, that we have a lot of customers and companies who are leveraging multi-cloud in ways. Great. So how do we define what deployment type is needed for our customer? Look, if you go to a customer and ask them if they're running workloads in public clouds, for example, they say yes. Well, then you need to work on a deployment that is focused on public clouds, of course. Also, even if they are running public clouds, understanding if they're collecting and analyzing flow logs is also important, right? How are they doing that? Do they have any confidence that they are actually seeing everything that's going on in their public cloud? If they don't know what's going on in the public cloud, then it comes down to Stealthwatch Cloud and us consulting and telling them that there's a better way. There is a way that we can have visibility of what's going on their networks. So for the public cloud environments, for this deployment type, we call public cloud monitoring within Stealthwatch Cloud, right? I'm establishing this because it's important to understand from a licensing perspective, and understanding that from a licensing perspective also, public cloud monitoring is licensed per amount of effective megaflow, EMFs, per month, right? So this is how public cloud monitoring is licensed. What does it mean as part of public cloud environments to be sending data to Stealthwatch Cloud? It's about gathering data from AWS, for example. And with AWS, we have native VPC flow logs support. So basically, your customers can just export their VPC flow logs to Stealthwatch Cloud via API. And this integration happens all on the back end. This is API-based integration. It's native. It's very easy to set up for these customers over there. And we can also grab data from other sources from AWS, like CloudWatch, CloudTrail, Spectre, and Lambda. So even Lambda is a function within AWS that we can just grab data from, right? So if you don't know what VPC flow logs are all the communication that the resources within AWS they have, right? It's basically that flow data, but for AWS. And many companies, they don't even have this enabled on their environment. But if they don't have it, it's about time that they do. It's even more time that they leverage intelligence on top of all that. At the end of the day, Stealthwatch Cloud will be complementing AWS monitoring such as AWS Guard Duty, AWS CloudWatch. We are complementing AWS security by having this aggregate view of everything that's going on in multi-cloud environments. So that's great. And this is also true. We can also grab all multiple source data from other cloud vendors as well, right? So we can just set up a virtual appliance on their environment, a virtual sensor on their public cloud environment. That virtual sensor will basically grab everything that it knows, just redirect traffic, metadata traffic to that. That will be sending out traffic to Stealthwatch Cloud's environment and reporting it back to your environment. So this is what would happen with Stealthwatch Cloud for public cloud environments. So now let's just take a look here at what the visibility for AWS resource like Lambda looks like. So we have additional alerts for AWS, right? Stealthwatch Cloud then will take full advantage of additional data sources to provide them better security, visibility to your customers. So console login failures, it is self-explanatory. We're monitoring how many times someone's attempting to log into their consoles, all resources running on their AWS platform. But also, if your customer is leveraging AWS Lambda, which is a function, basically provide a code, basically to host a piece of code within AWS, we are also looking at spikes for invocation of those functions. So if someone is trying to abuse your customer's piece of code on AWS, we can alert for that as well. We can also look for multi-factor authentication changes on their AWS environment. So if someone has removed or added multi-factor authentication to a user account, we can alert them as well. So these are alerts specifically focused on AWS Advanced that we can grab because we just have this built-in integration with AWS. Finally, we can easily integrate them with all your current customers, right? So, current systems. What that means is our dashboard will integrate with AWS, as I said, Google Cloud Platform, multiple scenes that are out there that customers need to export those flow logs to. They can export to Stealthwatch Cloud, and even to web platforms, right? So from web platforms, what we've been looking at here is a seamless and integrated security architecture as well across all the board. So with many of these platforms, Stealthwatch Cloud Entity results in a great combination for customers. So we're able to enhance their monitoring and analytics across their network, helping them avoid blind spots that we know that can be caused when they have multiple systems. Finally, with Stealthwatch Cloud, we are allowing them to see consolidated alerts across all these multi-cloud environments, right? So they can see alerts from all their deployment locations within the same dashboard, which is what you expect out of something that is multi-cloud visibility, right? So why this is important? This is important because, once again, Stealthwatch can be deployed anywhere and everywhere, protecting even teams that aren't usually concerned with security, like DevOps. So DevOps are huge advocates of public cloud environments and Lambda functions within AWS. That's why I was talking about Lambda. So when you look at this sort of profile of people, they're not too concerned with security. It is important to understand that Stealthwatch is protecting even them. Great. So that was a public cloud environment. So what questions would you be looking to identify if a customer needs on-premise visibility? Well, are they able and are they trying to detect internal networks, network threats, like self-propagating malware, for example? Are they able to do that? Can they track host-to-host communication within the network that is not going through their firewall? That is an important question. Are they monitoring devices that cannot run security agents? So this is another critical security component here for Stealthwatch Cloud. Oftentimes nowadays we have networks that have printers, BYOD devices, IoT devices connected to the internet. Are we sure that they're being secured? Are we sure that the traffic that is running on those devices, that we don't have an antivirus installed on, are we sure that this traffic is secure? If we don't know, well, there's a better way to do that. There's a way to do security in them. Right? There's oftentimes malware that is propagated and set up in IoT devices that once they're in the device, they're just going to scan the network locally. They're not even going to try and go outside before they propagate internally. So this is why it's so relevant for this type of environments. Can they be sure about the changes in the network for compliance reasons? So all these questions will help you identify if StealthWatch Cloud is good for their on-premise environments. Finally, this is what the StealthWatch Cloud multi-cloud environment with on-premise would look like. StealthWatch Cloud would just be gathering data from public cloud environments, and it would also be gathering data from on-premise environments using a virtual sensor, a virtual appliance that can even be set up on a Raspberry Pi, for example. That's as simple and as optimized as that in terms of code, right? So you can just set up that sensor on their network. Of course, you wouldn't put on a Raspberry Pi on an enterprise customer. I'm just saying it's supported for very small customers, for very home users like my house, for example. But you can set up on a VMware, for example. That will then start gathering NetFlow and DNS data from the network, sending it out to StealthWatch Cloud for that alerting and that visibility. Great. So what is the private network or on-premise environment called? This is called private network monitoring, PNM. Right? There's a typo here. Oh, it's not public, it's private. Private network monitoring. And private network monitoring is licensed per the number of endpoints or devices connected to the network. So there's a difference here. Whereas with public cloud, we're licensing per EMFs, effective megaflows, because that's what we can see on public cloud. With on-premise environments, we are actually licensing based on number of endpoints connected to the network. Now, a great way to get started on on-premise environments then is understanding how many endpoints they have. And how do you identify how many endpoints they have? If you have no idea, well, you deploy a trial, right? A 30-day trial of StealthWatch Cloud on their environment, for example, and you can understand a little better what's going on in the network. And what does private network monitoring then provide to customers? It is about seeing then visibility on premises, right? So you just deploy virtual sensors. So those virtual sensors then will be collecting data from all of these sources over here. So NetFlow data, you can redirect SIEM flow log data back to your sensor, to your StealthWatch sensor. IPFix data as well. Active Directory information running across your network. All that data is then going to be sent out to your virtual sensor. That virtual sensor is going to redirect back to your StealthWatch Cloud environment. So you can see that our sensor is actually grabbing everything across the network, not just from your switches, not just from your firewalls, but from load balancers, application servers, threat detection appliances as well, like SIEMs and so on and so forth. So everything is sending it back to the StealthWatch Cloud platform. So what does it look like in terms of reorganizing or an organization for setting it all up? It does not require such, so right? It's just a matter of spanning a few ports back to your StealthWatch Cloud virtual appliance. Everything will be sent to your StealthWatch Cloud virtual appliance. It will then export syslog and SNMP data to your SIEM. You have a SIEM. So StealthWatch Cloud would be your first hop on the network for those type of traffic. That will then be just sent out back to your StealthWatch Cloud via a management tunnel that will have with StealthWatch Cloud dashboard. That is, of course, an encrypted private tunnel, right? And from a security standpoint, how does the virtual sensor connect back to the cloud? It's via an encrypted tunnel, encrypted with TLS 1.2 protocol, and it is using a key exchange that is one of the standards nowadays, one of the most secure nowadays, with a 256 bytes encryption. So what does that mean? It means that all your data is being securely transmitted back to your management platform. And StealthWatch Cloud is ensuring that stored data in itself is encrypted at rest, right? So everything that is sent back to StealthWatch Cloud is encrypted. So you don't have to worry about how your data is being handled by the provider, because if anything ever happens on their database, it's encrypted anyway. So from an offering perspective, and this is just closing in on StealthWatch Cloud, we talked about what offers do we have, what deployment types we have, what are the license types, basically 2 of them. Now we're talking about how to sell them. We can either sell them as an upfront subscription license, much like you would resell anything out of Cisco nowadays. So your customer would pay them for the whole term upfront, or you can have an SPLA agreement, service provider license agreement with Comstor, and have an offering for you as an MSP, so you can be billed monthly only for the services that you enabled in the previous month. So this is a very compelling selling method for customers. So it can either be sold as a resale or as an MSP offer. So this is StealthWatch Cloud in summary, right? Now, if there are any questions, just feel free to send them through the Q&A panel. If you're now, we're gonna start getting into titration. So titration is all about the modern application landscape, right? So what does it look like? What does a modern application landscape look like? You have applications that are running anywhere, that are changing constantly, and that are unique. That means that your piece of code is leveraging something that it's doing something that is not doing anything else in the world, right? So this is what we expect nowadays. And with the introduction of technologies like Kubernetes and containers, you can expect that to be even worse from a modern application landscape perspective in terms of monitoring it. How do you monitor an application or a container, an application that lives for a few seconds or for a few days, for a few hours? Well, you need a new security approach. That's basically what you need, right? What they then have all these platforms have in common? Well, customers have IPS, firewall, IDS all set up on their network. One or more of them forms of data loss protection. They are already enforcing that one way or another. There are also customers that have these applications. They likely have a security operations center team or a response team. Finally, they will have some sort of patch management in place. That is great. But what if they, how do they look though, in spite of everything that they have put in place there? How do they look for incidents that were not discovered for a few months or a few years, allowing them to be in an environment undetected? So how do you make sure that you're inspecting everything that's going on in your application in that way? So current security approach is not sufficient for data centers. This is the core message here. So for data centers, what we're doing and what Cisco is doing is empowering secure applications that run anywhere at the speed of their business, right? So by running anywhere, we are securing controls closer to applications, right? So whereas StealthWatch is looking at networks, looking at everything that's happening on the network layer, titration is shifting that visibility back to applications, right? We're having visibility on what's going on in applications there. We're also looking then in order to address the constant changes that are happening, we are proposing an automated security posture updates. This is very important. How do you make sure that your security policies are being followed and that you are applying the correct policies at all times for a given application that's on a network, especially when you have applications that are living for a few seconds, minutes, or days? You need to have something that will intelligently and quickly take action upon those functions, right? And for the unique applications that are sitting on a network, we are basically tailoring the security based on the application behavior as well. So Cisco Tetration basically delivers application-first security. So it's focused on applications using comprehensive workload protection capabilities. So Tetration capabilities can be grouped under 4 different categories there. First, how it can contain lateral movement within the data center using micro-segmentation. Second, how to identify workload behavior anomalies proactively. So we need to identify anomalies in the applications and on the applications that we're looking at. Third, we need to look then to reduce the attack surface and basically reducing the security exposure of our applications. And finally, fourth, we need to proactively know how to when application components try to deviate from compliance policy. So we need to continuously track security compliance. Finally, Tetration then is enabling security and visibility through a combination of sources, much like what StealthWatch does, right? We're relying on multiple sources to actually enable visibility in our application environment. So from a cloud workload protection, what does it look like? From a Tetration is basically looking at applications, looking at what network communications are happening with that application, what process or how is the process living in those applications. If there are any software vulnerabilities in the operating system running that application, we're also looking at that. And we are providing application insights. All of those sources, source information, source data, helps us create a baseline policy, right? So we're creating here what's normal for that application. We're assessing the impact later on. We're merging the intent from multiple people who are accessing that data, and then we're unifying policies running in that application, right? So all of that helps us create a segmented network. And segmentation is a process, not a single product, right? This is important to understand here. And segmentation also will improve the performance, ease troubleshooting, provide least privilege access, reduce attack surface, and enable regulatory compliance. So segmentation goes hand to hand with correct assessment of what's going on in the network. And in order to create then that baseline, we are then grabbing all the data from multiple sources, from auto-generated based application behavior. So we're looking at applications and everything that they're doing on their network, workload context and metadata. So we're looking at workloads that are sitting in VMware, and we're grabbing metadata from VMware. We're grabbing metadata from Kubernetes. We're grabbing metadata even from DNS that is coming and going through that application. We're grabbing information from user and user groups as well. All of that helps us create a unified policy for that application. And this allows for policies that are focused on business outcomes, right? So having multiple sources of data within Tetration allows us to create policies that are focused on business outcomes. Now, adaptive application segmentation, much like what we were talking about before, is about having this consistent application micro-segmentation for any workload, anywhere, right? And Tetration will allow you to do that. So you can have the same, basically the same adaptive policy created on your network, on your network that is being tracked by the workload, no matter where your workload is sitting, right? If that workload is sitting on AWS today, and tomorrow you decide to move it on premises, with Filtration you can make sure that your security policy is following the workload, no matter where that is, right? So it doesn't matter where your customers deploy their applications. What we want to do is enforce this microsegmentation, in a unified and consistent manner all across the board. And if you're sure then how your policies will affect your environment, what Filtration will do is give you the ability to test the impact of what the policies you're creating and how that policy will affect and impact your network based on historical data, right? The Filtration keeps a feed and a database of everything that happened in the past in your network, and it can simulate new policies, changes in policies for specific applications based on historical data and how that would play out in your network. If that's going to shut down specific communications with internal services, with internal people, you can see all of that with a simulation of policies that Filtration can do. So how does the dashboard look like? So Filtration has a web interface. So this is Filtration's dashboard. There are a number of demos that you can access on the cloud to have a look at that if you wish to. What is important to notice here is that on the left-hand side here, we have our workspaces, including the applications workspace, the security workspace, performance, and so on and so forth. So this is how we navigate through the dashboard. Once we select applications, we can see all the discovered applications in there. That is, so all discovered applications in a given network can be accessed and found in the application workspace. So this is fairly straightforward and easy to do as well. That's all good. But how do we identify then behavior anomalies in our workloads? Well, we need then to be looking at the process behavior anomalies. We need to be able to detect common anomalies based on predefined rules. That's what we're doing. Identify anomalies based on MITRE techniques and tactics. So MITRE is basically a number of attack techniques that are being documented by a number of specialists and security specialists around the world. So MITRE is starting to be a standard in how you identify attack techniques from hackers. And having that integrated into Filtration greatly helps us identify when such tactics are trying to be used and leveraged in our environment. So we're leveraging that information from MITRE 10 to identify anomalies as well. Finally, we're looking then to detecting malicious processes running in the workloads based on hash information. So we're checking that hash information for processes against Talos database. So you would have remembered Talos from the last session. Talos is our threat intelligence group that also provides threat intelligence to all our security products. So we're constantly checking those processes hashes against our database. And we can whitelist processes that are running in workloads and get alerts if new processes spins up. So this is important because whitelisting is the best security model, right? Not blacklisting, whitelisting. So what's the difference? Blacklisting, when you're blacklisting, you are assuming that everything is enabled and allowed by default, and you are effectively selecting what you want to block. So in the better security model, what you have is everything shut down by default, nothing goes through, but what you know that is secure, right? So only what you know that is secure and that you trust is sent through. That is whitelisting. This is why whitelisting here requires a lot of visibility, a lot of intelligence from the network, so that a policy enforcement and advanced security analysis can happen, right? And whitelisting is where a good system will be shown to you guys and to a customer, right? When it allows us to effectively and efficiently set up that security model in an environment with the less friction available, and Tetration strives to do so. So looking at network communication anomalies as well, not only are we looking at application anomalies, but we're also looking at network communication anomalies. So we're detecting what communication is happening between hosts or applications in the world. And then we're correlating that with other forensic events to determine if there's a potential data leak, for example, happening in an application. So if you have a database application that needs to be secured, well, look no further, you know what you're looking at. You need Tetration. And by leveraging this host telemetry and machine learning, Tetration will generate policies that can layer on policy enforcement, right? So we're leveraging host telemetry alongside network, and all to generate policies that can be layered on policy enforcement. Alerts, we can also alert to northbound systems, meaning that if we have alerts happening in our network and we want to export that to SIEMs, we can do that as well, right? So we can send that alerting back to something else in our network, something that is aggregating all alerts in our system, in our environment. When it comes to reducing attack surface, what Tetration will do is look at software vulnerabilities. So identifying known vulnerabilities associated with software packages and operating system kernel. This is something that StealthWatch wouldn't do, for example, right? So we're trying to position the highlights of Tetration versus the highlights of StealthWatch, the solution, right? So Tetration is looking at hosts and applications, and even looking at then vulnerabilities that are known for operating systems. We then can find out how many workloads have the same vulnerability, for example. That is all within the Tetration dashboard, so we can easily navigate through the dashboard and get information right from the dashboard. It correlates information with forensic information from its database. We can grab more information about the nature of vulnerabilities prioritization, so we can prioritize alerts as well. And finally, we can set up policies to take specific action, right, when we see a specific vulnerability in our network, and a specific vulnerability that is attached to a given severity, right? We can quarantine servers that are identified within a given priority, for example, to make sure that they're not infected, or that they're not, so that hackers cannot leverage that vulnerability for their own intents. So Tetration goes further than just looking at network behavior from the host, and it also looks at OS behavior, right? It's looking at what the operating system is looking like in terms of its security posture as well. As for ports, we're also looking at ports processes and correlating this vulnerability data as well. And so just looking at operating system, network communication, and ports that are open and closed on a host gives us then this unified view and this greater visibility across this host. And correlating all that data gives us then a score for that attack surface, right? This is the important thing here. Tetration is creating that, well, is gathering all that data from multiple sources to create an attack surface score for your application, right? For your environment as a whole, and for applications as well. So you can then determine if a given process is associated with software with a known vulnerability, for example. That's great. What about segmentation policy compliance? With Tetration, you can then basically create policy that you need. If something ever deviates from that policy, you're alerted in real time, right? So right here, you have your policy. Traffic is permitted as per policy. So if anything is identified here as non-compliant, you easily see that on your dashboard in real time, and then traffic can be rejected to the policy per whatever you created. So this generate notifications to SIEMs and other systems as well when these events occur. So we're effectively looking in real time for anything that's deviating from the policy. And the security dashboard brings it all together, right? So as I said before, it's all about the security score, the attack score that I mentioned earlier. So you always want to have the best score possible. And what the dashboard will do is easily tell you if you need to improve your vulnerability postures, you need to patch your operating systems more often, for example. If you have hashes, oftentimes you have hashes that are known to be malicious, for example, you would be knowing here. The attack surface score will also make part of this overall score. Forensics score tells you if there's any past events that are known to be malicious. Data leak is if there is any host that is sending out data out to the internet inappropriately. And segmentation basically tells you if you have hosts that are running on a network that shouldn't be talking to other ones. So this overall security posture is an aggregate view of all the many things that we're looking at in internet network with filtration. And it gives you an idea of what to improve in your network. Finally, to achieve workload here, we recommend iteration to achieve workload security. What that means is protecting workloads all across the board everywhere. So having visibility anywhere through a combination of sources regardless of the infrastructure. That's what we recommend with iteration. From a deployment perspective then, just to close in on iteration, we have flexible consumption models. So iteration can be deployed on premises or be sold as software as a service, right? So iteration can be sold as a hardware appliance managed, hardware appliance for data centers, and there's even a virtual appliance option. And if you need to deploy it as a software as a service, we also have an offer by Cisco that is fully managed by Cisco, completely SaaS-based, that is suitable for any customer. Although here in New Zealand it would be for medium to large customers, but yeah. So this is the iteration basically, and you can sell them in terms of 1, 3, and 5 years. Great. I guess this will be a session break. Hey everyone. So let's just get back to session. Yep. I'm going to continue with the last two products, which is ICE and Duo. Now, if you guys, I know you had scheduled it for 1 hour. If you guys are busy, feel free to jump out of the session. We're recording it, and we're gonna send you the recording afterwards. So yeah, if you can't make it today, that's all right. But we'll send you the recording later on. So let's continue on with ICE and Duo just to finish off stage 2 delivery. So ICE, let's talk about Identity Services Engine. So what is ICE, right? So ICE is our basically our NAC, our industry-leading network access control and policy enforcement platform. So network access control means it's a service that is either blocking or allowing someone from entering the network. And at a later stage, what we're also doing with ICE, not only are we looking at when people are coming in, but we're also looking at what are people doing inside, right? When we see someone has breached one of our policies, ICE can actually go back to someone that is internal and say, look, you should not be doing what you're doing. You are going to be placed in quarantine for a while. So you're going to your shame corner for a while until you're put into play, right? So this is what ICE would do. Not only look at the interest, but also look internally. So ICE is seeing everything that is a network because it's gathering data from your wireless access points, your wired devices as well, from remote users connecting through the VPN. We are controlling everyone's access and segmenting them in the network, making sure that everyone has access to what they should have access to. And finally, we're sharing this context between ICE to other security systems. right, via APIs and PX Grid. This is what ICE is, right? Basically enforcing access policies. If I would have to define something that ICE is in layman's terms, I would say it's a product that tells us who is entering the network, when they're entering the network, what they're doing, what are they supposed to be doing, where they went, where have they gone to, how are they connecting to the network, what's the health of the device, are there any threats in the devices, any threats that breach any CFS scores, for example. So we're looking at all of that, and we're making intelligent decisions based on that. That's what ICE is. So why customers buy ICE? There are multiple, multiple ways to deploy ICE. Common one, for example, is device administration. So you need something that will secure your administrator's access back to devices. That would be a TechX plus server. ICE can be your TechX plus server, right? So a few years back, Cisco had this secure ACS to do that. That was a full appliance dedicated to TechX login, TechX access to devices. That has been put in end of sale a few years back. Now it's been replaced by ICE, right? So ICE can effectively do this device administration policy server and also allows for the security connection back to those devices. Another common scenario to deploying ICE, if your customer doesn't need device administration, that's good. They can just deploy guest access security with ICE. What that means is ICE is going to be granting your guest networks, providing your guest access a guest portal that can be fully customized. We're going to look into that later on. You're then going to be able to choose how you would approve guest access to the network. So ICE can be your guest access solution, right? It's a full-blown guest access solution with even social media integration and so on and so forth. Also, ICE can be your asset visibility product. So if you don't have Stealthwatch Cloud, for example, and if you have ICE and you want to leverage ICE for that as well, ICE can be your asset visibility product. Because we have device profiling. What device profiling does is basically give us the ability to look at a large database of devices that we have in our database of devices, and basically look at what sort of traffic they're doing, what sort of traffic we're looking from those devices, the hosts, and try to perform them and put them on profiles based on that information. We can also customize profiles with ICE. So with Stealthwatch Cloud, you would have roles attached to hosts and to devices automatically. ICE can do that automatically, but you can also manually change that, and you can manually change that to something you created, which goes even further than manually changing it. It can also be your identity-based services, meaning that you can look at 802.1x, Easy Connect devices, and passive ID devices, and making sure that you are allowing access to devices that are connecting the way you know them, right? That is what's important here. So network resources are added, and network resources are attributed to a host based on what how they're connecting from, for example. So lots of other scenarios here. BYOD, software-defined segmentation, so automatically segmenting your network, meaning when someone is joining the network, you want them to be redirected to a specific group or a specific VLAN. ICE can do that. Context exchange, so you can deploy ICE solely for one of these features because they're all in their own very important and very unique in their own sense, but it can also do everything, right? One of the important ones that I would like to highlight here is compliance and posture. So one of the common scenarios for ICE is understanding what's the state of hosts connected to your network, what are they connected from, how are they connected, if they are following your device guidelines with integration with an MDM, for example, or an EMM. And also what this allows us to do by checking their compliance and their posture is to take actions on this, right? So remember, I was talking about ICE looking at when people are coming in, but also performing internal checks on their postures and making sure that we're placing them in quarantine when they're out of them. ICE can do that using change of authorization, right? So if the device ever goes out of compliance when they're inside the network, so imagine a Windows machine or a Mac machine is infected by an antivirus after they were authenticated, ICE can look into that information and see and tell, look, this host is no longer compliant to our network. We should move that to a quarantine VLAN so that it doesn't affect other devices in our network. This is done by change of authorization, and so on and so forth. So threat-centric NAC is also an important one, which we're going to get to in later stages. And SDA, software-defined access, and DNA Center rely on ICE for security, right? Because DNA Center needs to enforce policies. It does that through ICE, right? ICE is an important component to enforcing policies in our network. So a typical ICE deployment then will include your ICE, and that can be a standalone virtual appliance or hardware. You may deploy multiple nodes for high availability, and you can even deploy that in virtual machines or dedicated appliances. Your ICE alone will not do anything. It needs to connect to identity services in order to secure network devices and endpoints, right? So ICE is just the glue that connects everything together and then enforces security between them. So your ICE will connect back to your identity services, no matter what they are. It will connect back to your security services as well, and correlate all that data in order to secure when endpoints can be users, devices, or things connecting back to your network. This is what ICE will do: effectively grab data from this place, understand what you have in a network, in order to enforce policies on the other side of things, on the enterprise here. And ICE can integrate with multiple vendors. It is completely agnostic. It doesn't rely on Cisco switches or anything of that sort. It just relies on technologies. Right? It needs 802.1x switches, for example. It needs access points that are able to send out MAC information, for example. Just basic stuff that most enterprise customers will have access to nowadays. And a typical customer journey, and this is how a customer would get started with ICE and how would they be able to leverage the full capability of this product, because as you've seen the use case, it's very broad in what it can do. So a typical use case is customers want to enforce security on their wireless network, on their BYOD devices, for example. So they buy ICE, they get started with wireless security, they start enforcing guest portal access with ICE, they move on to secure their corporate devices. Finally, they're securing their BYOD devices as well. They're enforcing policies based on BYOD devices as well. At a second layer, at a second stage of their deployment, they decide to further on increase their security on wired hosts. So they're controlling wired access now, leveraging 802.1x technology and MAC access control bypass, MAB, with profiling. So what that means is they're taking a step further and not only looking at wireless guests, but they're looking at wire guests, and they're also doing profiling now. So they're moving up the stack in terms of security. So they're with profiling, they're now able to identify what devices are connected to the network and create policies based on device types, based on vendors, based on operating system. This is what they can do with profiling, right? To create secure policies with those information in mind, with that information in mind. Now with posture, now they have successfully deployed wired and they want to go even a step further. So they go with posture. So posture means that they are checking what is the hardware status and the application status on of what's connecting to the network. So if they notice that then a given host connecting to their network is not compliant to their policy, they can enforce system compliance. They can put that device in quarantine, and they can make sure that that host will only be allowed back to the network once they, for example, update and patch their antivirus information, for example. Once they've done that, they want to move up even further. They want to start implementing segmentation with ICE. So what ICE will allow them to do is implementing security group tags for segmentation, meaning that with security group tags, what ICE allows us to do is create security policies based on business outcomes, right? Based on, we can provide segmentation and VLAN assignment to hosts, not based on VLAN numbers, not based on what groups they're connected to or what department they're from. But now with security group tags, we can intelligently and automatically basically say that anyone coming from anyone that is coming from the group AD of HR, for example, only needs to have access to these servers, not just to the subnet, but to these servers, to these network resources, and security group tags will allow us to do that without needing to modify ACLs at every single time, right? So it greatly simplifies that. So it automates the segmentation as well, and of course, group-based policies. And at a later stage, they're going to start enforcing rapid threat containment. What that does is integrating with security system partners to contain threats, right? So we're going to start exporting profile data and host data to those systems, and whenever we see posture change on their system, we're going to send that to other systems as well, and those systems will then be able to enforce greater security on other layers of the network that ICE is not touching, right? So that is a customer journey with ICE, and you can see that it's not a simple journey. Rather, it's something that builds up upon what has been done in the past, right? And starting from the easiest thing to do, which is the wireless deployment, up to the most complex one, which is integrating with other products. And you can see here that ICE supports multiple authentication methods. So I mentioned here 802.1x, MAB, I mentioned, or Easy Connect back a couple slides back. It also supports certificate-based authentication as well, and other ways of authenticating as well. So with one of the use cases of ICE, though, is device administration TACX. And while I didn't mention that on the customer journey, that is yet another very common scenario to get started with ICE. You just deploy ICE for your TACX platform. What TACX will do is basically allow you to secure your network from not only intruders, but even your own employees, right? So rogue employees trying to connect to devices that they should not have access to. So ICE supports the TACX standard. TACX is an acronym for Terminal Access Controller Access Control System. That is a great name. So what TACX does, it provides authentication, authorization, and accounting. So AAA verification for organizations' devices, right? So TACX is commonly providing role-based access control at command line console to ensure that only trusted users have access, but also to determine who is able to view and change various parts of the configuration. So what TACX is doing is looking at a console level, console line level, who can actually perform what actions in your devices, right? So what commands are allowed for that specific network administrator? What commands are allowed for help desk administrators on your devices, right? So that is what you have on the screen here is a good example. So network administrators will have, for example, full access to manage everything in your network. Maybe not the security devices, but full access to the network. Help desk, it means we'll only have a subset of commands enabled for those devices and none for the security. And if you had a third theme here, which would be your security administrators, they would only have access to your security systems, for example. So that TACX can help you enforce that sort of segmentation of access to devices. Now, visibility is about connecting networks using protocol data collecting from endpoints and network devices. ICE will then use a number of different probes. So you can see here, learning about the many kinds of endpoints that are connected to the network. These probes can include anything like NetFlow, DHCP, DNS, and so on and so forth. ICE can then use the sensor feature built into the Cisco network infrastructure to profile them and deliver security via radius accounting messages. Cisco AnyConnect can also be a source of information for ICE if it's installed on endpoints. So you can see the AnyConnect logo here. ICE builds a database of endpoints attributes it has learned about them, and as it collects profile data, ICE will attempt to classify these devices into endpoint profiles, like you can see over here, right? So it's learning from all the data here. It's gathering data. It's also grabbing traffic from those hosts. It's then going to start profiling them according to a database of device profiles that ICE has. And this endpoint database contains hundreds of device types in there that they can match devices against them. Then we will have the ability to update profiling policies automatically. So then that when new devices become available, administrators won't have to manually create profiles themselves, right? So this is what profiling does. Basically gathering data from lots of sensors, lots of probes, even AnyConnect, and establishing what endpoint type is connecting back to your network so that you can create policies based on that information. That is great. So let's look at one common example with ICE as well. It's about medical and IoT visibility. So this is something relatively new to the ICE family. We now have endpoint profiles that are dedicated to hospital or dedicated to medical devices. And we also have profiles built into ICE database that are related to IoT devices, right? And that data collection basically is shipping with ICE 2.4. We're now in release 2.6. That profiling collection is done by a PX grid from its database. What is important to understand here and to remember is that for all IoT devices, these are regarded as IoT devices here, all IoT devices also leverage, ICE leverages a technology called, or a standard called MUD, Manufacturer User Description, that basically validates what this device is, how these devices should be talking to the internet, right? And how these devices should be talking to the internet. So MUD basically is a standard that tells ICE, look, this is a profile of this device. So this camera should only be talking to this IP address. ICE then learns that from this MUD traffic, this MUD information from the manufacturer information. ICE then will start enforcing security in a way that that camera will only then be able to have access to that IP address that it needs. Nothing else will be required. So MUD allows this sort of automatic profiling for IoT devices. As for authentication and authorizations, well, there are many ways to authenticate. As I said before, you can leverage certificates, passwords. So authentication is about understanding who you are, and authorization, on the other hand, is identifying what you can do on the network. So authorization is about knowing that an employee can access servers, but contractors should not be able to access servers. So you start seeing a pattern here of how this chart looks. This is actually something that you can actually do in ICE with chart like similar to this. And it's straightforward to create authorizations based on that. And ICE will help you do that. Looking from a guest solution perspective, as I mentioned before, the guest solution that is built into ICE can be fully customized, right? So first you can customize what the guest portal should look like. That's the first thing that you can customize. Secondly, you can customize how guest account notifications can be done. So you can notify your guest account via email, via printing data or via an SMS to their mobile data. You can even customize portal language to their devices based on device information. So once you create your portal, you can actually tell that that portal supports multiple languages, and you don't have to customize it for multiple languages. ICE does that on the back end, and it just displays the portal in the language of that device's user. The device's preferred language is set up to. So that's pretty cool. Also, we support social media login. So if you want to allow your users to log in by logging into Facebook, for example, they can. And we can manage guest accounts via REST API as well. And there are many ways that we can also customize how to approve them, right? So we can approve them via just a hotspot, just always approving them. They just need to agree to the terms. We can have a self-registered where they just provide their information via social media, for example, or we can even have sponsors that are on our side on an enterprise approving their access. And sponsors is an interesting way to do so because we would have, for example, managers or a plant manager or a branch manager to actually approve access to a given network based on our security policies. And finally, sponsored guest access is when someone is authorizing them, creating their account and sharing their credentials back to the user. So the sponsored guest access is fully managed by the sponsor. They then communicate the host, the guest, what the credentials are. So these are the three different guest ways to deploy in an ICE. And ICE also supports full guest and sponsor portal customization. So ICE BYOD solution. So BYOD solutions require something that is able to identify what BYOD device is connected to the network. So profiling them, first of all, and later on, defining what resources should be given to a device that is connected to a network that is not part of our corporate, right? So devices in there. So it's just important to understand here that the BYOD solutions included multiple features like single or dual SSID provisioning, so you can have the guest connecting to the same SSID as they're going to be using, or they connect to an SSID to first provision their device, then later on to use the internet. We can create access based on MDM policy, meaning if we deploy MDM back to these devices, we can trust them or not. We can have a native supplicant and certificate provisioning back to these devices. So we can trust these devices for a number of days before they are not trusted anymore and they need a certificate. And we can even leverage our internal CA for BYOD certificates. So you don't have to deploy your company certificate to secure those hosts. You can just leverage our ICE internal CA if you want to. And if you have an internal MDM, you can integrate with multiple MDMs there with ICE in order to leverage access based on MDM policy, for example, so that you're checking the posture of that device when connecting back to the network. As for posture and compliance, so compliance for mobile devices is basically done by integrating ICE with mobile device management solutions, as you saw with BYOD on the previous slide there. This means that ICE can obtain compliance of devices against the policy of those products, and that means things like knowing when was the last day that they checked in, what is the device model, the device operating system, is that device jailbroken, are they enforcing pin lock, for example. All these attributes here that can then be used to check compliance and posture, right? This is what we're looking at here. So based on that device compliance status, ICE may or may not permit access to the device or put them in quarantine if they're non-compliant or if they're vulnerable, right? What they can also do, what customers can also do, is deploy any connect to obtain posture of Windows and Mac OS devices for compliance, right? So any connect can also be used to check compliance for the device if they don't have an MDM provider. And since many customers then are already using AnyConnect, you may want to integrate everything into AnyConnect, right? One of the takeaways from this right here is the policy checks between ICE and MDMs can be a lot. So there can be operating system version. You can check what model of device is connecting back to the network, what is pin lock status, what's the manufacturer's name, jailbroken status. So there are many policy checks between ICE and the MDM. And ICE, finally, ICE leverages, ICE is leveraged by MDMs for compliance and posture. Just looking then at, I was talking about AnyConnect and how AnyConnect is important for checking the posture. AnyConnect can also be used for multiple other security services within the Cisco security portfolio, including providing VPN services. The AnyConnect client can also be looking then at this network access manager, which is basically looking at what you're connected to. You can also do web security with our web-based CWS. We can look at posture, as I said before. We can even put umbrella services into AnyConnect and even AMP services. So all our clients that we can deploy as standalone clients, we can include into AnyConnect. So if your customer is already leveraging AnyConnect for a VPN, you might as well just embed umbrella, embed AMP in here as well to deploy all the services within the same agent. That's great. Also, ICE can also integrate with MFA, right? So I was talking about services, and now I'm talking about how ICE can integrate with one of the newest security products that we have in our portfolio, which is Duo. So ICE can basically proxy Duo authentication on premises, and Duo will basically verify this second factor authentication, right? When looking here at connecting to the network, ICE is able to use not only their identity, but many other attributes to make their network authorization decision, right? So as I said before, not only looking at the device, but looking at other information on their network as well, who they are, what they are, so on and so forth. And all those source that is grabbed from the network can then be used to tag this traffic and this host to a group, to a scalable group. And this is going back to sending that group information back to switches, back to the network across VPNs and so on and so forth. So tagging data, this is what we're doing here. We're just looking at all the data, the source that we're grabbing from the network. ICE is then tagging that traffic, sending that across through PS Grid, REST API, or syslog to other products so that we can reuse this context, right? So this is the importance of having ICE in your network. Just tagging traffic. So imagine someone is connecting, an employee is connecting from a corporate-owned device, and they're going to be tagged with tag number 1. I mean, the network then is going to be told that tag number 1 is the biggest level of access that we can have in our network. So therefore, they can have access to everything in our network, for example. And the switches are going to know that. The Firepower, the Stealth Watch products are going to know that. Even other third-party products will know that. And even Meraki will know that nowadays with adaptive policy coming into their one of their feature set. Well, it's part of their feature set. So when you had a guest connecting from a BYOD device, you would naturally have a lower level of access. So you'd have a different tag number associated to that host. So you'd have tag number, and I'm just being random here, tag number 30 means that that is a guest user, that a guest user should not have access to anything in our network, so the switch should not allow any access to that device. That traffic should not be going through the data center, for example, and so on and so forth. So you're enforcing security at a network layer level intelligently, right? And one of the core messages of doing that and how to do that is by leveraging PX Grid, which is basically this integration system between ICE and other systems. And ICE is the core component of a PXGrid platform. So basically, ICE can send context to partners. Partners can send information back to ICE. ICE can also mitigate action, so it receives an action from a security partner, like McAfee, for example, an endpoint protection device that tells ICE that now this sort of devices should not be connected to the network. ICE is then going to mitigate and block all those devices from accessing the network, and context brokerage as well. So we can use ICE to share security information between eco partners. So partners that did not have integration between themselves can actually leverage ICE's PXGrid to do that. Finally, what PXGrid will allow us to do is a full-blown rapid threat containment. So we're going to be able to contain hosts that are now infected whenever we see them. So imagine the malware enters a device here, AMP for endpoint, and that device is protected by AMP for endpoint. AMP for endpoint notifies Cisco. Cisco then changes that device, learns about that threat. That threat then is sent is informed to ICE. ICE then checks that to see that Jim's device is not affected. So it changes to threat detected by AMP, and threat severity is high. What ICE decides to do then is quarantine that device from the network. So that is what rapid threat containment would do in the network. And other security products like StealthWatch also leverage ICE for enforcing RTC. So not only AMP can do that, but also StealthWatch. If StealthWatch realizes that there's something malicious on the network, it can send action data to ICE, and that ICE will then start enforcing security on the network. ICE is then going to quarantine or block access from that given malicious network on the malicious host on the network. Also, we have a vulnerability assessment as part of ICE by leveraging vulnerability assessment tools like Tenables or Rapid7s, Q Assurance, and so on and so forth. What that means is ICE is integrated with these services, and when a host connects back to the network, this on-premises scanner is going to scan Jim's endpoint. It's going to send back to the Tenable or Rapid7 or whatever vulnerability assessment tool we have is going to assess that. The report is going to be sent to the assessment platform. The assessment is going to inform ICE what is the vulnerability assessment score for that host, and then ICE is going to take action based on that information. As you can see here, the authorization policy in this example states that if the vulnerability assessment score is greater than 5, then we should quarantine that host. In this case, we're quarantining Jing because his vulnerability assessment was too high for our network. So when vulnerable endpoints are trying to connect to the network, ICE segments it from the network because of its threat-centric approach. And for group policy, finally, this is similar to what we were looking before in terms of devices, users coming in versus destination. So PXGrid can also be used for group-based policy. So the employee coming in from subnet A can not access anything on the network, right? For example, and so on and so forth. As for SD access, ICE is the core component of software-defined access. ICE acts as a network identity sensor enforcer, and as the SDA or DNA, digital network architecture, is responsible for network designing, policy, provisioning, and assurance. So DNA is not worried about enforcing or not worried about security. It relays all that responsibility back to ICE, right? With those two products deployed, you then finally have SDA, software-defined access, which is being able to then define network intent and dictate mechanisms of the network connectivity, not the other way around. So understanding what you have on the network and what are the business outcomes and enforcing policies based on that. So ICE and DNA center integration is core for SDA to be deployed to customers, right? So that integration happens between through PXGrid and REST APIs, right? So DNA is basically looking at policy workflows, fabric management that is coming from the campus fabric here, and ICE is looking at authorization authentication policies, groups, and policies. DNA Center leverages network data platform for analytics. As you can see in this diagram, APKM is also leveraged by DNA for automation, and ICE is leveraged by DNA Center for security, right? There are three components to DNA Centers working correctly and working in its full state, I would say. So network data for analytics, APKM for automation, and ICE for security. And group-based policy simplifies segmentation. I mentioned earlier before about how tagging traffic makes things easier, so you don't have to create new ACLs based on new users or new VLANs. Rather, you just tag traffic based on user identity and user information, right? So this is called basically group-based policies. And this is called TrustSec. So you can see over here that we have employees sending traffic red, light red goes to data center server, traffic green from supplier also goes to data center server based on our policies, but non-compliant devices, traffic, they're not sent to servers, they're discarded, right? This is what the segmentation allows us to do, right? If you have the traditional path, however, what you need to do is statically change ACL every single time there's a new VLAN or a new device coming into your network. So you need to statically create and manually create rules on your routers, perhaps on your data center switches as well, and so on and so forth. So in order to simplify that deployment type, we are leveraging TrustSec to make it just based on tags, based on intelligent segmentation, I would call it. And what a TrustSec policy looks like, this is what it looks like. So this is the TrustSec policy, as you can see it within ICE. This tells us that employees can talk to employees, but are blocking malware. So we're not allowing that access between employees to employees. Employees to contractors cannot talk. Employees to development servers can talk. So we're allowing IP addresses. However, employees to PCI servers, we're blocking them, and so on and so forth. So this matrix can be applied to all devices in our network, right? And this is a lot easier to manage and a lot easier to understand than lines of codes with ACL, right? And what each of these blocks, what each of these correlations they have attached to them effectively is a security group ACL attached to them, right? So rather than creating policies on subnets and whatnot, you just create groups, and these groups, they have security groups ACLs attached to them. And finally, we integrate then ICE with SDA segmentation and security. So using segmentation via TrustSec with DNA Center, DNA Center and ICE can then force security via other devices by PXGrid as well. So what are the deployment options of ICE? There are multiple deployment options. First, let's understand what's the architecture. So there are multiple personas, that's what we call them. There are multiple ways that an ICE node can work. So policy services node, for example, policy administration, monitoring, troubleshooting, PXGrid controller. Not all of them are mandatory for deployment. So some of them are optional, like PXGrid controller is not necessary for ICE to work at all. But a working environment will require at least one of each here. And if you have a large environment, you can distribute your ICE nodes in ways that some ICE nodes will only be running policy services nodes, some other ones will only be running policy administration nodes, and so on and so forth. And that can be distributed across the network. so that you offload, so that you don't worry about overloading your servers that way. And how you can deploy them by an appliance, dedicated appliance, or a virtual appliance, and that can be in a single node or multiple nodes, as I said before. And the newer appliances can support up to 50,000 current endpoints on a standalone deployment. Or if you're talking about a distributed environment, you can support up to 2 million concurrent endpoints. So that's a lot. So you can see here that the number of endpoints is really large, right? And how does the multi-node ICE deployment works? Basically, many devices are talking to themselves, right? So the administrator basically operates the policy administration node. Policy administration node is then organizing everything else on the back end. It's talking back to the policy services that is effectively looking at authorization policies. Policies then are sending back logs to the monitoring, sending contacts back to PXGrid. PXGrid is being fed off monitoring and PAN, and is sending that to partners. And every single thing that is managed is sent back to the administration node, right? That's the main management node that must receive all the new information. Finally, DNA center automation is then sent back to switches there, and is sent it as a REST API callback to ICE. And as I said before, PXGrid is optional in the environment. Deployment scale, so you can have all 4 services in the lab and evaluation for up to 100 endpoints. Virtual appliance, so that's a common scenario for labs and evaluations. I run a lab like that in my Leap Center. You can have a small HA deployment with 2 nodes, both nodes running PAN, monitoring, and PSN. And if you have a medium, you can distribute some services, much like PSN can be distributed to multiple devices, whereas PAN and monitoring could be in high availability. And these are some ways that you can deploy ICE in distributed environments. It just helps to highlight that it is highly scalable, right? And it's fully distributed as well. So you can centralize data centers or distribute PSNs across geographies there. What are the install options? I said that there's appliances. They're called SNS, Secure Network Server. There's VMware options, KVM or Microsoft Hyper-V options as well. And this is the licensing that you have for it. Now, this is a very important screen here, so I would recommend you take a screenshot of it, keep it stored somewhere. And this is a great help for everyone trying to understand what features are included in what ICE licenses. Now, once you go through all the services here and all the licenses, you'll understand that base licenses basically give you control, plus licenses basically give you context, meaning profiling in PXGrid, and Apex gives you compliance, gives you posture and MDM integration capabilities. So if you had to summarize, if you need AAA and group-based policy, go with base licenses. If you need profiling, you need base licenses and plus licenses. This is, you can see here at the bottom. To apply device admin plus or ICE Apex, you actually need base licenses first, right? So base licenses are always required. And then if you only need compliance, you just need Apex and base, for example, right? Just keep an eye out on that. As for some of the common use cases here, group-based policy, guest services, device profiling. These are the ICE licensing and deployment types that we have. Finally, just getting into Duo. Duo is about protecting the workforce. We have talked about Duo a couple weeks back or a few weeks back. So protecting the workforce is about establishing trust, verifying identity, and device hygiene. right, before granting access to cloud and on-premises apps. Cisco secure workforces with Duo, mainly by verifying trust when users, devices, and applications are accessing network, right? So by looking at these three things, user, devices, and applications, we can actually, Duo can actually establish trust, right? And you can reduce workforce vulnerabilities by establishing trust in user identities, right? Not in user devices, not where they're connecting to. And why Duo? So there are a number of reports here that state that nowadays we have a lot of issues. I wanted to highlight that 95% of breaches involve compromised credentials. And compromised credentials, they're most commonly got from phishing attempts or phishing hacks. So if you ever have compromised credentials, it was likely part of a phishing campaign somewhere in the world. So Duo protects the login process better than anyone. What that means is we support a large number of applications, and we have a very easy way to implement that to users. So users usually love how easy it is to prove and understand what's happening on your credentials with your application sitting on your device. So what are the Duo packages? So first of all, the MFA is about establishing trust, right? And the packages that we have are, first of all, Dual MFA, which is all about authenticating users, Dual Access, which is about enabling BYOD and enforcing adaptive policies, and Dual Beyond, which is about establishing user device trust and remote access alternatives. Dual MFA, as I said before, is about establishing trust via MFA, provides all the main features that you expect out of an MFA solution, multi-factor authentication solution. So it provides multiple support for multiple MFA types, so you can authenticate your identity via Dual Push or U2FA, which are the preferred ways to authenticate. Or you can also support a hardware token that we sell. The Duo sells mobile passcode on devices, phone callback, so on and so forth. So we support multiple ways to authenticate a user's devices. I want to highlight two of them. Duo Push. Duo Push is just putting it on the spotlight because it's the most popular and secure method of secondary authentication, and that happens because it is secure because the private keys are stored securely and encryptedly in mobile devices, and it is adopted by users because it's very easy to approve or deny information, and you can just see everything that's going on in a matter of seconds on your device. And Duo Push can also require additional biometric authentication, so that's another added benefit to it. Another common security authentication method is universal 2FA, right? Universal two-factor. These are basically security keys. They are extremely user-friendly. It's just a USB stick that you put in somewhere and just tap an authentication button here. They're very secure because it cannot be phished. That means that the encryption certificate is stored in themselves, so they cannot be replicated anywhere else. But they are sold by other partners like Cubico, for example. I myself, I got a couple of these here. I use them for my personal services. They do require, however, browser support. So you need to be running Chrome or an updated Edge browser to actually leverage U2F authentication. So that's a big if there. There's a big caveat there for this type of authentication. Talking about the next licensing type. So MFA is the first one. Dual Access is the second one. Dual Access is about gaining visibility into device hygiene of every device. So not just can you do all your MFA needs, but you also can look at what's going on in your device hygienes. I wanted to point out that that looking at device hygienes is basically giving you the ability to create policy controls based on groups of users and applications, right? And based on endpoints insights. So you can create policies that can actually filter out according to what browser, operating system, or version is actually running on a device that's trying to access your application. So if you're trying to access an application from a jailbroken iOS device, you can block that access altogether. If you're using an Android that's hacked as well, you can just block that access to your application just by looking hygiene of the device. So the value behind dual access is enabling BYOD, so bring your own device access to your environment in a way that will not push users back against setting up dual in their mobile devices, right? Because all they need in order to access their applications with dual access, for example, is just setting up their applications from their mobile stores, and that's it. If they're accessing from their browser, they don't need anything. If they're also accessing from their Mac or Windows applications, they don't need anything. So authentication device then there is about reducing risk and of stolen devices. So you can have multiple devices authenticated to your applications, right? And you can then reduce risk by not allowing access to devices that are out of date in your applications in your network. As you start realizing what Duo is doing, you might be thinking to yourself, why would I set up Duo and not an MDM? It's all about the user's perception, the employee's perception to how they're accessing the network. If they're using a BYOD device, they're likely not going to want to install an MDM application on their personal devices. But if they're using Duo, they don't need to install MDM. All they need to do is install the Duo application, which is not monitoring everything that it's doing and everything that's happening, and cannot enforce control over the devices. It can only look at hygiene of the devices. It's basically agentless. So it's in a passive approach. It's more friendly for users. As for the last licensing tier, Duo Beyond. Duo Beyond is about enforcing policies for corporate and versus personal devices. So identifying corporate versus personal devices. That's what Duo Beyond is all about doing. And unblocking unauthorized devices. This is what it's doing. The value is application and group level policy control and restricting access to only devices that are managed by your MDM or EMM. So it's in terms of maturity model for Duo, your customer would first be looking at dual MFA, very likely that they only want to confirm identities. At a later stage, they would want to gain visibility and enforce contextual access policies. Finally, when they're very mature in their security status, they will want to secure access to all applications and inspect devices for trust and control with MDM integration. And it's at that stage that Duo Beyond comes in play. Now, what are 4 common use cases for Duo? Duo can authenticate user identity for remote access, and this is a highlight here. Keep that in mind. It can also enable self-service endpoint remediation, secure access to any application, and enable policy-driven access. So these are 4 common use cases for Duo customers there. And by securing access to any application, it means that even with the first licensing tier with MFA, you can already protect any application, any of these applications over here, and many others as well, because we can basically customize via SDK and via third-party integrations, Duo security with other products as well, with other applications and other customized applications as well. So not only can we support proprietary apps via APIs, we can also support all Microsoft shops, products, cloud services, Unix devices via SSH sessions, SAML applications, so cloud-based applications there, so on and so forth. One way Duo enables secure access to all applications is by shifting access control decisions to all these apps, right? So access is shifted back to the device, the application. And understanding what apps the customer wants to protect is vital for a successful deployment and proof of concept. So just understanding what applications they're running is really important, knowing what they want to achieve. Duo easily stands apart from the competition because of how easy it is to use, how flexible it is in terms of coverage, in terms of applications that it can protect, how quick it is to deploy it. And I want to highlight this over here because being easier to deploy means it is going to be easy to adopt by users and finally be able to respond quicker to threats. High success rate. Customers usually love it. There's a lot of security controls built into it. It's a low TCO and high responsive platform as well. Duo is completely managed out of a web dashboard that is served off of the internet. And Duo reduces workforce vulnerabilities at each stage of the journey. So establishing trust in user identities, gaining visibility into devices activity, ensuring device trustworthiness. This is one of the way that vulnerabilities are checked and reduced within the workforce. And trusting worthiness is done at each device of time of access. So we evaluate trustworthiness of each device when they're accessing an application. So that's an added benefit of Duo, right? So we don't trust devices because it connected before. Rather, we're checking it again every time they're accessing it. Now, Duo for industries. There are many ways that Duo can be used for industries. I want to just highlight here these points over here. Most importantly, for financial institutions, it's all about, medical institutions, about HIPAA requirements are being met by the platform. Protects research and student financial data. That's important for education customers. For corporate customers, they're looking at protecting against phishing attacks. Save monies and needs management for all industries, really, and deploys to all BYOD users without friction at all. So looking from a financial services customer's perspective, what are the main benefits of adding Duo to their security stack? There are many. These are some of the topics that why they would be looking at it. Aligning regulatory requirements is a big one. Also, securing devices, improving security posture, protecting every application, and meeting GDPR standards, for example, and PCI DSS is one of them as well. So this is why they would want to look at Duo. As for healthcare, they would be looking at easily deploying it, meeting HIPAA requirements, as I said before, and so on and so forth. As for retail, reducing vulnerable access points is one of the reasons why they would look at it. Complying with PCI DSS and GDPR requirements is an important point why they would be looking at Duo, because Duo helps them do that, helps them achieve that. Reducing burden on IT and improves productivity because it's so easy to deploy. That's great. So looking at proof of concept and deployment options. So steps to consider here would be to consider when deploying Duo is deploying, first of all, a proof of concept, defining the deployment type, deciding how to enroll users, setting up policies, and then be happy. That's easy. That's all there is. When looking at a proof of concept, steps to a successful proof of concept mean that you need to define what applications the customer wants to protect. Set up, also, ideally, you set up a proof of concept in a controlled environment, copying the customer's real environment, such as a sandbox, in order for them to realize Duo's value. So using a sandbox is good for them to realize Duo's value in context of their own work. Define milestones, and then you can start your trial for free through this link over here. So how to deploy Duo? There are many ways. So you can integrate Duo via Radius and LDAP, via Duo authentication proxy. You can secure cloud applications by deploying your access gateway in-house and then leveraging ID stores based off of the internet. And you can even integrate with Office 365 as well. There are many ways to integrate with Office 365. And I think their message here is they got this, right? So they can integrate with single sign-on pages, dual access gateway, and so on and so forth. There are two ways to enroll device users. There are two ways to enroll devices for user devices, right? So first of them is to pre-provision them manually or inline enroll them. So this pre-provision them is basically IT doing everything. So IT administrators are importing users, then sending out click activations for users Users chooses their chosen devices, user the device information, installs the apps, and then it is activated. So this is pre-provisioned. Is IT admins do that, sends their link, and off they go. As for inline enrollment, though, the admin secures the applications, and then when the user attempts to, and this is the most frictionless way to deploy it, inline deployment, right? Inline enrollment. So you just deploy security to the applications, not to the users. When the users try to access the application, then they're guided through the device enrollment. So from that point onward, they choose what device they want, they enter device information, download the app, and off they go. And which are applied. And then finally, once you enroll the users, you need to start applying policies. So policies are basically 3 levels: global, application, and user group policies. So these are the 3 policy levels that you have to set up. Global is a default one that is always applied to every single application. And then you can set up policies per application and per user group as well as you require. Finally, just comparing the licensing there. This is what features are included in each licensing. And this is also something that you need to use for your reference. Now, I'm already a bit out of time, but this is just to close in on the session. Thank you for your attention. Duo can be sold in 2 ways, basically reselling subscriptions the way you do regularly. So selling a subscription term, or you can become an MSP partner. That is a different journey. We refer and we recommend that all our customers resell Duo via the resell model because it's the way moving forward, if I would have to say it. But you can sell them in both ways. So next steps for you would be to access the full content and the stage 2 exams in that link over here. So I'll be sending out that presentation later on for you to take a look at that link. And the next steps then we'll do for you to go through the 4 quizzes of the products. So I know it's a lot. It's 4 quizzes. Each has at least 20 questions, but all the answers should be found in the slide deck. If not, you can go through the content to get more details. Then you have to fill in a form with Cisco that is also available through that link that I sent. Once Cisco approves you from that form, you can just send me the confirmation, and then points will be awarded to you once confirmed. We recommend you doing that before attending to the stage 3 for visibility and segmentation that we're doing on the first week of September with Cisco and Comstor Australia as well. So it's a joint delivery that we're doing. Thank you for the attention.